Okay, so for this lesson we are going to do, again I'm going to combine a few things in one. First of all, we're going to very briefly look at matrices and use them to draw things in a scrolling game. So for a scrolling background, you can do it a bunch of different ways. This is only one option. You could, for example, you could have the image of the background just scroll past the player, draw it a couple of times over and over now, like a conveyor belt as it moves past the player. And that works fine, but you would then probably have to also move everything else past the player too, just so the player can stay in one place, which isn't much of a great benefit in my opinion, which is why I don't tend to go that approach if I can avoid it. So instead, I'll be using a matrix. So the player does actually move. He moves through the game world, but he's followed by a camera, so he's always stationary relative to what you see on the screen. So the other things in the game aren't actually necessarily moving. The player is, and the camera is. So matrices, I don't want to talk too much about them yet. They look kind of like these. This is a 3x3 matrix over here. It's a 4x4 matrix. That's a 2x3 matrix. And these are each spot in the matrix is a number or a variable. And in XNA, we use a 4x4 matrix for pretty much everything. You can also represent vectors as matrices. So a vector like 5, 10, it could be represented as a 5 above a 10, or 5 above a 10 and a 0, 0 being a z, so that's x, y and z coordinates in a 3D world. Because it has to go with a 4x4 matrix though, we typically have 4 x, y, z and w. W is not really that meaningful at this point. There's not a fourth dimension, don't worry, we're not time travelers. But it has to be there in order to use the 4x4 matrix. So what are matrices for? Well, they can be used for translation, rotation, scale, projection, different kinds of projection, so you can view things differently on the screen, orthographic like an isometric type style, or perspective, which is the usual 3D style. They can project shadows, they can be used in pixel perfect collision detection of rotated objects, solving systems of equations, and more stuff like that. Loads of stuff you can do with matrices. The only thing we want is the translation matrix. Translation is just means move stuff around, so you translate from one coordinate to another. And the way it does that is basically the x, y, z and w are all multiplied by 1, and then you add on the x, y and z. And that's kind of what will happen when you multiply a 4x4 matrix by a 4x1 matrix like we saw a minute ago. For example, if you take this matrix here, the identity matrix, one's all the way down the diagonal line, but with an x and a y in there. Basically, you take your vector 5, 10, and when you do all that multiplication, you end up with 5 plus 4, which is 9, and 10 plus 4, which is 14. You've got your new x and y coordinates. Seems like a long way around, and it is if that's all you're doing. But the thing about matrices is it does all those other things as well, and you can combine them really easily. So it's a good kind of field to get started in. Also, Sprite Batch has the ability to draw everything using matrix. So you can just pass in one matrix and then suddenly everything in the entire game gets drawn with this offset, and exactly like you'd expect from a camera. So let's go ahead and do that. So I'm going to take a slightly different approach this time. Here's one I made earlier in Blue Peter style. So I'm not going to type in the code as I go along, I'm just kind of going to highlight bits and show it to you. You can always pause the video to type it in if you need to. So to start off, we've got our usual stuff, graphics and Sprite Batch. I've put in our old Sprite class. There's a few changes there which we'll get to in a second. So there's a player sprite, and there's just a random object I've put in, because otherwise you wouldn't really see much happening when you move around in the game world. The random object is just there so you can see that you're actually moving. We need to define a view area. This is basically the size of the screen. It's going to be 00 is the top left corner, and 1024.768 is the bottom right corner. I've also defined a ground level. This is where the player will stop falling. The camera will also stop round about that level, not exactly that, because you want a small gap. You don't want the player to literally be standing on the bottom pixel. But yeah, so that's the player won't fall any further than that. There's a list of sprites for the bullets we're going to shoot. A single texture for the image, so we can just reuse that image every time we make a bullet. The gun's going to have a cooldown, which is on a timer, similar to the timers I showed you in the last lesson. There'll be a crosshair for the sprite. So instead of using the isMouse visible attribute, so you get a regular old pointer, I'm going to use a crosshair image of my own to represent the mouse pointer, and a couple of sound effects. There's also going to be a vector for the camera position. It's not defined at the moment, but it will be. And this new thing here, the scrolling layers, which I'll show you shortly, but there's 4 of them. There's a background layer, a foreground layer, and 2 middle layers. So they are kind of scroll at different speeds. That's called parallax scrolling. You'll see what I mean when it happens. So the game 1, all it does is it sets up the size using the view area width and height. Remember, that's 1024 by 768. But it's always a good idea to try and take magic numbers away from here and define them elsewhere. So that's what I've done. Game 1. Nothing initialized really, just calls up load content. So what content do we load? Well, we load in an image for the player. We position him somewhere in the game world. We load in an image for the random object, position that somewhere in the game world. We create new layers for the background, the foreground, the midground, and I'll come back to them when it's time. Load in an image for the bullet, or the bullets I should say, an image for the crosshair, and then the sound effects. Notice that bullet image, by the way, is just a texture, it's not a sprite yet. We're going to use that image to make sprites when you fire them. The game update. First of all, we're going to handle the player's input, which I'll press F12 here to jump to that code. If you press the A key, then you'll accelerate along the x-axis, and we're going to add in a flipping attribute. So there's a sprite effects variable, a sprite effects structure, sorry, enum, beg your pardon, which only has 3 options: flip horizontally, flip vertically, or none, don't flip. So if you press the A key, you're going to flip, and if you press the D key, which is move to the right, you're not going to flip. So it just uses the same sprite going different directions. I've added that into the sprite class. There it is, public variable called flipping. It's a sprite effects type. It defaults to not being flipped. These, by the way, are the only 3 things I've added: an origin, a rotation, so you can rotate sprites, and a flipping attribute, so you can flip them. But more on that shortly. And finally, if you press the space key, then you will get a burst of speed upwards on the y-axis. I've not done anything to stop you from jumping well in midair, so it's kind of going to be a Flappy Bird effect sort of thing. That's the player's input. And that's handle input done in the update. And then we're going to deal with the player's movement. We're going to apply some gravity so he falls down, apply the movement. Again, not a proper Euler implementation, but it's good enough. Some vertical friction, which is going to be different from the horizontal friction, because I wanted you to fall faster than you can move left and right. I think that feels more realistic. If you go past the ground level, minus the origin, because you're going to be drawing around the origin, so you have to get back. This will basically place your feet on the ground level, because the origin should, in this case, in most cases usually, the origin will be halfway out, down and halfway along the sprite. So this is basically taking you from ground level halfway up, and if you draw the player around that point, then he'll be drawn standing on the ground. Okay, so if you fall below the ground, then stick to the ground. That's what that's saying. This keeps our gun cooldown up to date. So the gun cooldown starts at 80, and it goes down by the number of milliseconds that have elapsed this frame, usually 16. When it goes below 0, then it also responds if you press the left mouse button. Then it resets the cooldown and shoots a bullet. Let's hit F12, see the code for that. It creates a new sprite, uses that image we had earlier, positions the sprite over the player, because the player is firing it. It gets a direction from, let's split this up a bit. It gets its direction from the mouse position. So if you take the mouse position, add on the camera position, because you may be scrolling. You're not scrolling yet, the camera position is 0, so it's not doing anything at the moment. But once it starts scrolling, you need to take that into account, otherwise you'll be firing way back on the first screen. And also we need to subtract the bullet position. So this gives you the direction, the sort of distance between where you clicked and the position you're at right now for the bullet. But that could be quite a long distance, and we don't want it to go too fast, so we normalize it. That brings the vector back down to a single unit in size. We then rotate it using ATAN2, so that it's rotated to match the direction it's going, and then we speed it back up again. So it's got a speed of 25. Once that's all done, we've got our bullet finished, so add it to the list and play a sound effect. There's your shoot method. Let's go back. So there it was, there was shoot. What we got left? Go through all of the bullets, all of the sprites and the bullets, column B as we go along, and then just update its direction so the bullets are moving. And finally, we handle collisions. F12. Update the hitbox for the enemy object thing. Loop through all the bullets. Notice I'm going backwards, this is quite common. So I starts at the count of bullets. So if there's 10 bullets, we start at number 9. So it's 10 minus 1 will take us there, because it would be numbered 0 to 9. And we go down 1 each time until we reach 0. Or go below 0, I should say. At that point, you don't want to go into the loop anymore because there is no object number minus 1. Okay, so for each bullet, we update the hitbox, and then if that hitbox intersects with our object, remove the bullet and play a sound effect. I guess you'd probably do damage there as well if this was a proper game, but that's enough for now. Collisions handled. And that's your update. So what do we draw? You'll notice I've got a few things commented out. That's kind of the crux of this video, so I'm going to show you them shortly. Clear the screen as usual. We're going to do a sprite batch begin. There's a bit of a difference in there, you'll see. I'll explain that in a moment. The background layer is going to be drawn, the player is going to be drawn, the random object is going to be drawn, but all of these are using a special draw method which you've not seen before. So let's have a look back at the sprite, for instance. I mentioned that the sprite now has an origin, a rotation, and a flip option. There's also a constructor method here, so when you construct a sprite, you can say new sprite, open brackets, and give it a texture. And when you do so, it will set up the image, but also it will calculate the origin by half of the image's width and height. So the origin is the middle of the sprite by default. It's public, so you can change that if you have to. You don't need to rotate around the center if you don't want to. But beware of side effects if you do mess with that. If you notice, there's also a draw method here. So you pass in a sprite batch. I've called it SB in this context. And that sprite batch will be used to draw the image in its normal position. But look at all this extra junk. This null here is a rectangle for animation. It's not animated, so that's why it's null. There's the color. Plug in the rotation and the origin. So it will be rotated if it'll be drawn rotated if you have a rotation value, and it'll be rotated around the origin. That's why the origin's in the middle. You usually want to rotate things around the middle. 1 is the scale, so it's basically the size is multiplied by 1. And then we tell it whether it's flipped or not. So a lot of parameters in there, but it gives you a lot of options there now. And the update hitbox had to be changed slightly. So the hitbox is no longer just positioned around x and y coordinates, but x and y minus the origin x and origin y. Because otherwise your hitbox is going to be positioned as if it was drawn around the top left corner of the image, which it's not anymore. It's drawn around the origin. And that's all that's really changed in the sprite. So what about the scrolling layer? Well, that's a brand new class. Class scrolling layer. It's got a texture. Every layer obviously has a texture. And here's the parallax values. So they're set to 1 by default, but you can change them when you create the layer. I'll come back to that in just a moment. The parallax tells you how quickly it scrolls. So with different layers with different parallax values, they will scroll at different speeds. This boolean here tells you whether that layer is on the ground or not. That will determine whether it tiles just horizontally or whether it also tiles vertically. For example, the building's on the ground, you wouldn't see extra buildings up in the air as well. If that is the case, you'll need to know where the ground is. So we get a ground coordinate y, which is made public, so we can have control over it. When you create a scrolling layer, this is the constructor method. So you can construct it using a texture. You can set the parallax values, or horizontally and vertically, like I said, and you can tell it whether it's on the ground or not. And all it does is it stores that data in those variables. That's all the constructor does. When you tell it to draw, and this is the only other thing in here, it needs to first determine if you're on the ground. There's 2 rectangles set up, first for destination and source, which are going to be used to draw it. So eventually we're going to draw the image. We're going to draw in a destination area on the screen, and the source rectangle tells us which part of the sprite we want to draw. But that will differ depending on whether you're on the ground or not. So If you are on the ground, if this layer of stuffed background images is on the ground, then the destination area we want to draw it at. Actually, you know what? I'll do the other one first. We'll come back to on the ground. If you're not on the ground, this is the thing that this will be basically the sky, and it's going to scale in both. Tile in both directions. So the destination area to draw on the screen. We start at the camera position because that would be the top left corner of the screen, and from that corner we go out however wide and high the screen is. So it's basically going to fill the screen, that destination area. What source area do we use? Because if we just do that, then it's not going to scroll properly. So the source rectangle tells us, well, use the camera's x coordinate and camera's y coordinate, but multiply them by the parallax values horizontally and vertically, so that it will go at whatever speed you want. And then obviously view area and width and height as well tells it to use the same amount of the image as you're actually filling on the screen. So it's going to be, you know, normal scale. So as the camera moves around, the x and y coordinates are going to change. This will just keep it pace with the camera, so you'll draw the area that you'll need to see on the screen. But this part here, it multiplies it by the parallax value, so it won't scroll at the same speed as the player. If it did, it would look kind of fake. But what if it is on the ground? Well, it's a similar kind of idea, but there's the int camera position x, same as normal. But instead of just camera position y, we have this much longer calculation here. So whatever the ground is, remember that was a separate variable, ground coordinate, so that tells us where the lowest point should be. So we have to come back from that point to draw downwards. So to start from that point and go back, the height of the image, however tall the image is, and that should position it properly, except we need to also take into account the parallax scrolling. So when you fly up into the air, it doesn't necessarily have to scroll away at the full speed. And it doesn't draw the whole view area. It draws the whole view area horizontally, but vertically it only draws as much as the image has, because you don't want a repeating copy of the image. As for the source rectangle, how much of the image to draw, again the x coordinate is the same, but the y coordinate is 0, because we start at the top of the image. If we're not drawing it tiled, we may as well start at the top. And we just use the whole of the image height. Okay, so going back to the game, we need to give it these details. So pass in the sprite batch, pass in the camera position, pass in the view area rectangle, we defined area. But the player and objects and stuff like that, I don't need to know all that, they just get given a sprite batch to draw with. The crosshair position on the screen is worked out by just getting the mouse coordinates and adding on the camera position, which at the moment the camera is still 0, remember. So let's see that in action. Okay, so only one background layer there so far. We can move around, I can press space to jump. The collision is not perfect, as you can tell. It's probably a discussion for me. But it works. You can fly off and fly back on, jump, etc. The background is drawn there fine. Let's take these comments out and you can see what I've been hiding. First of all, move the camera around. So the camera is going to reposition itself. It's going to be it's going to follow the player position, but it's also going to take into account the width and height of the screen. So it's going to go halfway back up and to the left. So the player should be in the middle of the screen, except if the camera goes too low. If the camera goes below the ground position, minus the height plus 50, so there's a little margin of 50 pixels there. So about 50 pixels from the bottom, the player should stop and the camera won't chase him any further. If you go past that pixel, then it stops at that pixel. Fairly common pattern there. What happens if we put that in? The camera does indeed chase the player, and you fly up in the air, it still follows you, and the background scrolls appropriately. Let's fire in some more backgrounds. Some more layers, I should say, they're not background. There's a middle ground 2 and 1, two separate middle ground drawn at different speeds, and a foreground. Let's look at their definitions again. I did say I'd come back to them. So the first one is the background. It's got a scrolling parallax speed of 0.2 in both directions, and it's not on the ground, so it repeats up and down and left and right. The foreground, however, it scrolls faster horizontally than it does vertically, and it is on the ground, so we need to define the ground coordinates. So the ground level, remember, was 700, so I've added on 68 to make sure there's no gap at the bottom of the screen where we don't see this image. And the midgrounds are similar, just scrolling a bit slower. Incidentally, the way I've written this, the vertical parallax is kind of inverted, which is I wasn't too happy with, but it does work. Let's see that working. These images, by the way, I got from OpenGameArt. It's called Industrial Scrolling Parallax Background or something like that. Okay, so fly up and you can see the first midground definitely scrolls way slower than the second midground, which again scrolls slower than the foreground. I say foreground, it's still a layer, but the actual foreground is the player and the enemy, and they obviously go fastest. They're at full speed basically. So there we have it, twin stick shooter, scrolling, matrices, and reverse loops again, origins, more classes, lots of cool stuff. Hope that's been some use to you. Speak to you later.